All right, hello everyone, and welcome back to the ACT Prep and Strategies for Math. Hope that you'll pay attention and get something out of this. We feel like all the strategies are important, but especially with the math section of the ACT, strategies in this section can really pay off for you. Some things to remember: you have 60 minutes and you have 60 questions. So plan on one question per minute. However, we're going to talk about that more in just a second, how you can strategize to do a little better. There are multiple choice questions. You have 5 choices per question. You can use a calculator, although all problems can be solved without using a calculator. Very important. Work the problems that you know first. Skip the ones that you are unsure of and return to those if you have the time to do that. And of course, read the instructions. Some of the problems are standalone questions, and some may have multiple questions linked to the same problem. And you see an example of each there. The standalone example or problem, you'll have one number and one question or problem, one answer. And then you'll have you have multiple questions linked to the same graph, table, or data. And you can see in the example there, it says the instructions say use the following information to answer questions 33 through 55. And there's a description and there's a diagram. You would use all of that to answer the questions 33 through 55. Something to keep in mind, and this is critical. The ACT Math, there are 3 sets of 20 questions. Now, it's not going to show up like that, but that's how it's designed. You have 60 questions total. It is designed so that the first 20 are the easiest, the middle 20 are a little bit harder, and the last 20 are the most difficult. We really believe we have to spend time and effort in the first 40 because we feel like those are questions we should be able to get right with some reasoning. Not that we don't feel good about 41 through 60. We can still get some of those questions right. But don't get hung up too much on the latter part. We've got to do well on the first 20 and on the second 20. And then the better we do on that third set of 20, 41 through 60, that's icing on the cake. Key strategies here. You have 60 minutes. That's 1 minute per problem. However, it is important to spend time on the problems that you feel you can get right. Please, if you don't hear anything else I'm going to say, hear this. Don't waste time on the most difficult problems that you don't think you can get correct. Come back to those if you have time. Spend time on the problems you believe you can get right if you spend some time on it. And what you will do, you'll skip some problems that you don't feel good about. With a minute left, if you have not had time to go back and do those problems, whatever you have with a minute left, you need to choose an answer choice and fill it in. Do not leave anything blank. So I'm going to kind of summarize that one more time. As you do the math, you work the problems that you feel good about. You skip the problems you don't feel good about. Come back to them with whatever time you have left. If you start to run out of time with a minute left, you start filling in answer choices, not leaving anything blank. I hope that's clear. A critical strategy. Again, you can use a calculator, but not It's not required. All the problems can be solved without a calculator. It's important to understand which problems you feel like you would need a calculator. It's in your best interest, and when you don't. The problems are designed to test your ability to reason. They're not designed to test your computation skills. And again, answer all the questions. Guessing gives you a 20% chance of getting it right. Leaving it blank gives you a 0% chance of getting it right. 20 is greater than 0, so let's at least guess at each question. Now Coach Beard is going to take you through several of the questions that we didn't do well on in the practice test as a group. So pay attention. We feel like this is going to help you understand some mistakes that you might have made on the practice test. Thank you.
Guys, this is Coach Beard. I want to first, before we get into some problems, echo some things Mr. Miller's told you strategy-wise with the math portion of the ACT coming up. First off, realize this, guys, most of this math out of those 60 questions is what I would consider fairly basic stuff. Right? A lot of it's even middle school math, some Algebra 1 stuff. Only those last about 20 questions is stuff where you start getting into some advanced geometry, some trigonometry, some math 2, math 3 concepts. So number one, you can do it. All right. The second thing, though, and what I consider the most important part of this section is the timing. And you keep hearing that. All right? You got 60 minutes for 60 questions. That's about a minute per question on average. You've got to go. Right? You don't have time to look around and stare at the walls and take a 5-minute break and put your head down. You've got to get on it. Okay. So you've got to read the problem, figure out a plan of action, and then go make it happen. And then you just got to have some stamina. Right? You got to stick with it for 60 minutes. And if you'll do that, you'll have a really good chance at success, because I know you guys can do this math. So I want you to keep hearing that. I want to keep echoing that because it's true. Okay. So with that, we're going to hop into 4 questions from that Case 21 test that the juniors took the other day. Numbers 3, 7, 10, and 15. So if you've got your booklet and want to follow along, those are the ones that I'm looking at. And I'm going to talk through several ways to work the problems, maybe a different strategy. And you take, what you can identify with and what best fits you. They'll all, of course, get us to the right answer, but, people look at things differently. So we'll see. Okay. So number 3 here, the first one says a model airplane is built so that the scale is 1.5 centimeters equates to half a meter or 0.5 meters. If the wingspan of the actual airplane is 4.9 meters, what is the wingspan of the model airplane? This is a middle school concept of setting up proportions, all right, and ratios. And we have what's called a scale factor. Okay. Now we're going to say, I'm going to let my fraction be the model as the numerator and the actual as the denominator. Okay. So if I follow along, 1.5 centimeters, that's the model, equates to half a meter as the actual. All right. Now, that's going to be equal to what's going on in the problem. And the actual airplane here that we're looking at is 4.9 meters. So that goes in the bottom, where our actual is. And the question, what we're trying to figure out is, what's the model up there? Right? I'm just going to call that X, because that's what we're looking for. Now, I've got what's called a proportion. A proportion, very simply put, is 2 equivalent fractions, 2 fractions that are equal. And you solve those by cross-multiplying. All right? Something you guys should be very familiar with. So if I cross-multiply that way, 1.5 times 4.9 is 7.35. And if I go this way, I get that's equal to 0.5x. Now, very simple one-step equation. I'll divide the 0.5 over, and I get 14.7. All right, there's our length in terms of centimeters of the model. So answer choice E. Now, one thing that you may have noticed, and I thought about it as I was working this problem the first time, is there's a difference in our units of measurement. All right, so we got centimeters, we got meters. Is it okay to have that in the same problem? And the answer is yes. And I want to show you kind of how it works out if we go through and do some unit conversions. if I can get these things to erase. All right, good enough. So what if I want to put them all in the same units of measurement? All right, how would that look? I'm going to put them all in centimeters. Now, that prefix centi, right, you should know, means 100, right? So you think about a centipede has how many legs? 100. So if I take that logic, there's 100 centimeters in a meter, okay? So if I leave 1.5 centimeters, now 0.5 meters, if there's 100 centimeters in a meter, then half of that would be 50. Okay, over here we're still looking for the top right. 4.9 meters, right? Well, 4 times 100 is 400. 0.9 times 100 is 90, is 490. Now I've got everything in the same units of measurement. And I want you to see how it still works out the same way. If I cross multiply 1.5 times 490, I get 735. And that way it gives me 50. And if I divide by the 50, then I get 14.7, just like we did before. So even though you notice there's a difference in units of measurement, not a big deal here. Okay, so there's the first one, proportions cross multiplying. That's a middle school concept that everybody should be familiar with. All right, next one. It reads, the first 4 terms of a geometric sequence are 2, 6, 18, and 54. What is the 6th term of this sequence? All right, let's talk generally first. What is a sequence? A sequence, talking about numbers, is any ordered arrangement of numbers. So what that means is they're not just thrown in there randomly. There's a reason why we get to the next number. Right? There's a pattern, if you want to say it that way. Now, a geometric sequence means that that pattern and that logical way we're getting to the next number is through multiplication. So look in there, 2, 6, 18, 54. How am I getting to the next number by multiplying? I hope it's not hard at all to see, particularly in those first 3 numbers, that we're multiplying times 3. Okay, 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, so forth and so on. And one thing, if numbers get more complex and you can't see that just immediately like you can in this one, if you'll take any term and divide the one before it, the result is what's called the common ratio, or that number that we're multiplying by. So take, for instance, the 6, divide the number before it, 2, 6 divided by 2 is 3. That's that number we said. 18 divided by 6 is 3. 54 divided by 18 is 3. It'll give it to me that way. Okay? Let me show you 2 ways to work this. The first one is technical, mathematically. There's actually a formula for a geometric sequence to find the nth term, in this case the 6th term. And it's this: G sub n equals G sub 1 times r to the n minus 1 power. Now that's a lot. What does that mean? G sub n represents the nth term of a geometric sequence. In this case, we want the 6th term. All right, G sub 1 should make sense as the first term. Right? The first term in our sequence is 2. R is the common ratio, that term we used for what are we multiplying by. We said that was 3. And now n minus 1, n's how far out we're going. Well, they want us to go 6 places. Subtract 1 off of that is 5. So if I type in 2 times 3 to the 5th in my calculator, it spits out 486. Right there is the 6th term. Okay? Now, this is one where, and you're talking about saving time there with that 1 minute per problem, you don't have to do that. You know, if I wanted the 56th term, yeah, I don't want it to hit times 3 50 times in my calculator. All right, but just going out 2 more, I've already got 4. I could get there very easily if I just know that the common ratio is 3. So the first term was 2, second one was 6, third's 18, fourth is 54. All right, well, how do I get to the 5th one? Times 3. 54 times 3 is 162. And now to get to the last one, the 6th term, the one they're looking for, times 3 again, and there's that 486. So although this is how I do it mathematically, guys, if I've only got a minute per problem, let's look for a shortcut. And that's definitely one where I can do that. Just multiply times 3 2 more times. Okay? Talk about sequences in Math 1 a little bit, but really that's just multiplying numbers. You don't have to have a depth of knowledge with sequences to get that one correct. All right, on to the third one. Number 10, this is basic. This is area of a triangle. You probably even learned this in late elementary school. I'm going to show you 2 ways folks like to write area of a triangle. They're both equivalent mathematically. You use whichever one works for you. So it says the area of a triangle is 34 square units. If its base is 17 units, what is its height? Well, this whole problem is dependent on me knowing the area formula of a triangle. And notice they don't give it to me. That's something that by the time you're a junior in high school, we expect you to know, this simple formula. Here's the way I write it. Area equals 1/2 base times height. An equivalent way to write that, and the way some people write it, is area equals base times height divided by 2. All right? It really doesn't matter which one you use here. Okay, so they give us 2 of the 3 variables. We know the area is 34. We know the base is 17. That leaves us 1 variable, h, the height, to go solve for if we just plug it in and go find it. Okay, so I'll do the one on the left first, then the one on the right, and I'll show you that it doesn't matter how you look at it. It's the same. So area was 34 equals 1/2 times the base, which they say is 17. And then there's the h, 1 variable to solve for. So on the right side, what's half of 17? That's 8.5. And now if I just divide by the 8.5, 34 divided by 8.5 to get h by itself is 4. Okay, now look at it the other way. Plugging it over here, 34 equals, up top, we know the base is 17, don't know the height, divided by 2. So I'm going to get the 2 off the bottom by multiplying, the opposite of division. 34 times 2 is 68. That leaves me 17h in the numerator falling down there, and 68 divided by 17 gives me 4, just like we did on the other side. So no matter how you look at it, area of a triangle, plug in 2 of the 3, solve for the height, the remaining one, we're going to get 4. So answer choice B. All right. Again, guys, that's not difficult math. All right. That's very basic stuff that we expect you to know and that you can do. Let me keep reiterating that. All right. Everybody can do that problem. Here's the last one. The circle graph represents Andre's monthly budget. It says in order to keep the graph proportional, and what you can't see there is it says, what should the approximate central angle of the measure for the rent be? Okay, so I got to know a definition. What is a central angle? Right, well, central means the middle. You think about Central Park, right in the middle of New York City, right, in Manhattan. So a central angle all centers around right there in the middle of the circle. All right, now they want to know specifically what's the central angle for the rent. Okay, well, that's right here. So what is that? I've got our 5 answer choices on the right. Now notice I've got 2 acute angles right there, less than 90. I've got a right angle right here, and then I've got 2 obtuse angles. All right. Now, hopefully, we all can recognize that this central angle with the rent is not acute. All right. So I think those 2 are automatically out without even doing too much at all. Okay. A 90-degree angle, of course, looks like an L. Like right here with entertainment, that looks like a 90-degree angle. If I combine that and the savings, those 2. Right, this isn't 90 degrees. Right, it's not over here. So that's not the case. Hopefully, you can all see that that is an obtuse angle, the one that we're looking at with the rent. Okay. Now, so I'm down to 166 and 180. So how do I distinguish between those 2 obtuse angles? Here's what I want you to think about. The full circle is 360 degrees all the way around. This line right here cuts that circle going through the middle in half. So that angle would be half of the 360, which is 180. Now that's not ours. We're a little bit shy of that. In fact, see the answer is 166. We're 14 degrees shy of that, and the answer is 166. So there's not any work. I didn't work anything out there, solve an equation or anything. I just had to identify, first off, where's the central angle in the middle? Right? Which portion am I looking at, the portion with rent? And then just kind of thinking through the difference in acute, right, and obtuse angles, right, getting me down to 2 answer choices, D and E, realizing that a circle's 360 degrees. We were just shy of half of that, just shy of 180, which left us at 166. Okay, so there's 4 examples. And notice all those came in the first half of the problems you worked on that Case 21 study there and that pretest in the math section. So those are some of the easier questions. Right? Hopefully those are something that as we go through them together, you see me work them, something that you say, I can get those. I can be successful at that and just go make it happen. All right. So good luck on the ACT. Do a good job. And we'll talk some more ACT math in the near future. See you guys.